Are you evaluating Mend for application security testing and wondering how it fits into your engineering workflow?
In this review, we will walk through what Mend does well, where it may be less of a fit, how it applies AI and automation, and how it compares to other solutions in the market. By the end, you will have a clear understanding of whether Mend aligns with your DevSecOps priorities, development velocity, and compliance obligations. Mend is an application security platform that embeds into the software development lifecycle to identify, prioritize, and remediate vulnerabilities before they reach production. Historically known for software composition analysis, Mend expanded its coverage to include static application security testing for custom code, container and image scanning for cloud-native workloads, and supply chain controls. The unifying theme is policy-driven governance and developer-friendly remediation tooling so that teams can address risk without slowing delivery. A central question buyers ask is whether Mend uses AI. The short answer is yes. Mend applies machine learning and data-driven correlation primarily to improve prioritization, reduce noise, and surface context that makes remediation faster. It evaluates multiple signals, from CVSS severity and exploit references to reachability in your code paths to rank findings more intelligently. Mend does not attempt to rewrite your application logic automatically. Instead, it augments human decision-making with fixed suggestions, safe upgrade paths for dependencies, and automated pull requests where appropriate, often via the Renovate bot maintained by Mend. Let's break down the core modules. First, software composition analysis identifies risks in open source and third-party libraries, including transitive dependencies that arrive through your package managers. Mend supports popular languages and ecosystems such as Java with Maven or Gradle, JavaScript and TypeScript with NPM or Yarn, Python with pip and Poetry, .NET with NuGet, Go modules, Ruby gems, and more. The SCA module flags known vulnerabilities, surfaces upgrade recommendations, and enforces open-source license policies. This license governance is a critical area for enterprises that must track permissive versus copyleft obligations and ensure legal compliance in distributed codebases. Second, Mend includes static analysis for proprietary code. The SAST capability integrates with development environments and CI pipelines to detect common vulnerability classes like injection, insecure deserialization, path traversal, and insecure cryptography. Results can be shifted left into IDEs such as Visual Studio Code and JetBrains, and validated in pull requests so teams catch issues before they merge. You can configure quality and security gates to fail builds if severity thresholds are exceeded, or allow developers to proceed with waivers under defined policies. Third, the platform extends to containers and images. Mend can scan base images and layers stored in registries such as Amazon ECR, Google Artifact Registry, Azure Container Registry, and Docker Hub. It correlates vulnerabilities in OS packages and application dependencies to show which images, deployments, and services are impacted. For Kubernetes users, this ensures images are evaluated continuously and not only at build time. Combined with policy gates and CI and registry scanning, teams can block risky images from being promoted. An important Mend capability is SBOM management. Mend can generate and maintain software bills of materials in standard formats like CycloneDX and SPDX, enabling traceability for audits, vendor assessments, and regulatory frameworks. SBOMs help you answer which components are in each application, their license obligations, and their vulnerability posture. This is increasingly essential for compliance with procurement requirements and secure software development frameworks. On the workflow side, Mend integrates with the tools teams already use. Source control platforms such as GitHub, GitLab, Bitbucket, and Azure DevOps benefit from pre-merge checks, security annotations and pull requests, and automated fix branches. CI systems including GitHub Actions, GitLab CI, Jenkins, and Azure pipelines can run scans as part of every build. Ticketing integrations with Jira and ServiceNow translate high-priority findings into trackable work items, preserving accountability across squads. Developers can receive notifications in Slack or Microsoft Teams, and platform teams can enforce consistent policies across repositories and business units. Let's talk about prioritization and accuracy. One of the biggest pain points in application security is alert fatigue. Mend addresses this with context-aware evaluation that looks at whether a vulnerable function is actually invoked by your code, often called reachability analysis. It correlates vulnerability metadata with application call graphs
and environment data to promote the issues most likely to be exploitable. The result is fewer false positives surfacing to developers and clearer guidance on what to fix first. While no tool eliminates tuning entirely, Mend's ranking and policy engine aim to reduce the time from finding to fix and to align remediation with real risk. What about remediation speed? For open-source dependencies, Mend offers upgrade suggestions and can open pull requests that bump to safe versions testable within your CI. Renovate, the open-source dependency update bot maintained by Mend, can automate routine dependency updates with safeguards like grouping, scheduling, and compatibility checks. For custom code issues detected by SAST, Mend provides recommended code patterns, references, and links to secure alternatives, helping developers apply fixes quickly while learning secure coding techniques. In terms of deployment and data handling, Mend is primarily delivered as a SaaS platform. Many enterprises pair SaaS with on-premise build agents or proxies to control source code exposure and network egress. Mend supports policy-based controls to minimize sensitive data sent to the cloud and allows organizations to align with internal security standards. As with any security product, you should review data flow diagrams and compliance attestations as part of procurement. How does Mend compare to alternatives? Mend's historical strength is SCA and license governance at enterprise scale, now complemented by SAST and container scanning. If your top priority is comprehensive open-source risk management, SBOM automation, and automated dependency upgrades, Mend is a strong candidate. If you need extremely deep static analysis for a niche language or advanced container runtime protection, you may compare Mend's depth with point solutions or platforms like Sneak, GitHub Advanced Security, GitLab Ultimate, Veracode, Checkmarx, Sonatype, JFrog X-Ray, or cloud-native security platforms like Prisma Cloud. Many organizations deploy Mend alongside cloud posture tools to cover application and infrastructure layers holistically. Where does Mend excel? It excels in environments with many repositories, polyglot stacks, and rapid release cadences. The combination of policy enforcement, intelligent prioritization, and automated pull requests can meaningfully reduce mean time to remediate and improve compliance standing. Teams benefit most when they make Mend part of their standard developer workflow. Pre-commit checks in IDEs, mandatory pull request gates, and auto-generated tickets for high-severity items. Security champions and platform engineering teams can then measure adoption with dashboards and SLAs. Potential limitations include the need for policy tuning to match your risk tolerance and the fact that no static or composition tool can fully capture runtime context without additional instrumentation. Organizations seeking unified infrastructure and workload protection will still want to complement Mend with runtime defenses, container posture tools, and cloud configuration scanning. Finally, while ML-driven prioritization is valuable, it should be reviewed alongside architecture knowledge, business context, and threat modeling for critical systems. If you are assessing Mend, run a proof of value across a representative set of services: monoliths and microservices, front-end and back-end, containers and serverless if applicable. Measure signal-to-noise ratio, developer adoption, build time impact, and the speed at which automated pull requests land and stay green. Validate SBOM exports against your audit requirements and ensure license policies align with your legal guidance. Engage both platform engineering and application teams early so the rollout becomes a standard part of delivery rather than an afterthought. In summary, Mend provides a comprehensive application security platform with particular strength in open-source risk management, SBOM generation, and developer-centric remediation. Its use of AI to prioritize and reduce noise, combined with automation through Renovate and CI gates, helps teams fix what matters faster. For organizations that need consistent guardrails across many codebases and want to accelerate secure development without burdening engineers, Mend is a strong option to consider.